Okay, I'm gonna go ahead and get started. Hey everybody, thanks for coming. Hope you had a good lunch. It's a great day out there here in Vancouver. Welcome to cleaning up your service mesh mess with service mesh. Try to say that a whole bunch of times in a row. You'll find that you'll interchange those words and it's a little bit of a Freudian slip because it is often a mess, and even if you have a service mesh, you may also have a mess. So we'll talk about that here, and I'll talk about a lot about what a service mesh is, why you want one, and we'll do some demos and some fun stuff like that. A little bit about me. My name's Brian Redmond. I work at Microsoft. So yeah, we can get his last name is Redmond jokes kind of out of the way. I start all of my talks with that. I guess there's no other way to do it. I've been at Microsoft 18 years. So at this stage, it's the longest relationship I've ever been in. So I work for the Azure Global Black Belt team, so I really just help customers adopt solutions on our Azure cloud, primarily open source technologies, things like containers and Kubernetes and so forth. And so that's really what I focus on, but I do travel around and do talks about various topics related to things like that. I live in Pittsburgh, Pennsylvania, in the Northeast, and I spend a lot of time kind of outside of work, running marathons and being outside and things like that, so love to run. In fact, that picture, I was just in Amsterdam doing the same talk at a different event, talking about service mesh there. So I spend a lot of time on that topic as well. And what it really comes down to is microservices. And you guys probably have a good bit of experience with microservices. I'm not going to spend a bunch of time talking about the benefits of microservices and all the reasons that architecture has become pretty popular. But on the other hand, it also brings along a bit of difficulty. You can find this post out on Reddit, where someone said, hey, I got a call that microservice X is down, what would you check? And if you read the thread and the answers, it's actually pretty funny. Some of the responses are somewhat of a joke, but are probably somewhat serious as well. Really, how will you figure out what's going on? It ends up being something that brings a lot of challenge, and that's why there's typically some trade-offs that come with microservices. And so I'm going to do a little bit of a demo here first of this application. This is a sample microservices app that I have. These are node.js APIs. The front-end application basically displays sort of GeoJSON on a map of various phenomena, whether it's earthquakes, weather, flight kind of data. It's just for simulation for the purposes of this. But you can see I've got a series of APIs in the middle there that call another layer of APIs below, and it's too bad that text is in blue. But the bottom line is you have APIs calling backend services. If something's broken, how do we determine what's going wrong? And in general, each of those APIs isn't just one running instance. I usually have multiple replicas of that running so that I have resiliency and load balancing. So it starts to become super difficult to troubleshoot. And I want to show you kind of an example right out of the gate. We'll do a demo. Before I even tell you what a service mesh is, we're going to do a demo of one here. And this picture, I don't think has anything to do with the demo or anything. I just thought it was a really cool picture. So we'll start with that. So we'll take a look at my cluster. I'm running this on Kubernetes in the cloud. We'll talk again a little bit about where Kubernetes fits in, but I have a few different clusters here that we'll be working with in the demos. And so this cluster actually is running linkerd. And so that's going to be the service mesh that we'll use here. And you can see the application itself. Again, if you're not familiar with Kubernetes, we use things like pods and services to run these applications in the cloud and expose them out to the user base. And you can see we have all of our data APIs, flight APIs, and so forth, and then our front-end UI that we'll bring up here in a second. And so I'm going to go to port 8080 for this application. And you can see this is the UI that we have. And so this dashboard kind of shows me the status of each of the APIs. So I have flights, quakes, and then the other one that's weather. And you can see we're already seeing an error in the application. The weather component doesn't work. Normally, when we click on one of these, we see the data come back displayed on the map here of all the different flights. When we click on weather, we're getting a 404. Something's wrong with the weather service. And in theory, we could just pop back over and do some troubleshooting here on the weather API. But we have, again, 3 instances of that. What logs am I looking at? Well, I can look at the logs of each of the 3 ones, and invariably, it'll be the last one I check. And I really need to kind of figure out exactly where this thing is broken. And this is where linkerd actually comes in. It's super helpful. I can do a linkerd tap, and I can say, I want to tap into the deployment for weather API. So all of the instances of that weather API. And so now I'm plugged in live to that particular service. And we just go back over here and refresh the dashboard. And you can see we've gathered some data about what's going on. And it's a little bit hard to see here, but basically what's going on is the weather API called the data API, which is what we expect. It's actually the one talking to the database. And the response we got was a 404. And so what it actually tells me is not only that I called the data API, but it actually shows me the API path, get latest weather here. And that's what got the 404. So if I want to figure out what's going wrong in my application, I know exactly what part of the source code this is in. It's in the data API. And if I go into my routes here and look around, I see get latest weather. And I can know exactly the line of source code where this thing failed and what went wrong in this particular case. Super helpful from the standpoint of my service mesh actually digging in, intercepting traffic, and helping me figure out what's going on. And you can see I had actually planted a 404 in there. I mean, we're just faking scenarios for demo purposes. But you get the idea kind of how that actually helps me out. All right, so hopefully that makes sense from a demo standpoint. Let's talk a little bit about what we mean by service mesh and what I was actually using there. Now, first of all, in a lot of cases we're talking about microservices. A lot of times the viewpoint is that these are the answer to everything, kind of the answer to all of my problems. And I think it's pretty clear that that's not the case. So often the next step is, okay, let's use containers. Everyone's talking about containers. They must be the answer to everything. And of course, we know that that's not the case. Containers are super helpful as far as helping me deploy these applications in a consistent fashion, helping me scale out my microservices and doing things like that. But I probably need more than that. So it's certainly not the answer to all of the problems. Well, then Kubernetes must be the answer to everything. And I don't know that you can read a technology article in the last sort of 6 to 12 months and not hear about Kubernetes. It's a super powerful platform, can do quite a bit at orchestrating containers, but it isn't the answer to everything. There's still quite a bit that is left to you to solve. And in fact, I've spent a lot of time in Kubernetes, and it actually produces quite a bit of headaches. There's a lot to learn. I spent so much time learning about it, and yet I learn something new about it every day. So really, when you have this complicated system of containers that you're orchestrating and your microservices platform is everywhere, there's definitely something that's missing. And so you certainly need more. And what I would venture to say is you need some level of observability. We saw that in the case of the demo I just did. You need to understand how are these different services performing? Are any particular replicas performing slower than others? Maybe I have a VM with a memory problem, and it's actually affecting a particular instance of this. How well is it performing today, and is that good compared to our past history? Maybe we want to have some level of benchmarking on a service-to-service basis. And so we need much better observability data. And we also need really what I would just call intelligent routing. I don't just want to do load balancing and just sort of round robin traffic to all these instances of these microservices. I want my load balancer to use that observations and metrics that we were collecting and maybe stack rank the instances of this and send the traffic to the ones that are responding the quickest and constantly reevaluate that. Maybe I want to do some kind of advanced routing to do things like A/B testing or canary testing, and I want to actually control exactly how much traffic goes to which versions of my application that are out there. I want to be able to customize the rules and do whatever I want on top of something like a Kubernetes. And I also need things to help me with security. This is the kind of thing that comes up quite a bit where it's often considered the last thing. Like we build our system, and at the very moment before we're delivering it, someone says, hey, we need to encrypt all traffic that's on the wire for this particular application. And so then everyone scrambles to try to figure out how to do that. Or there's a policy of doing it, but it's not enforced very well from team to team. We've got developers using different programming languages, and they're not implementing it in the same way. So those are just some of the things that I think are missing. I would venture to say you could probably come up with quite a bit more that was missing as well. I would also say there's a lot of ways to solve these problems. In many cases in the past, people have kind of had a shared library or package that all the developer teams would use and implement in their applications. And in an organization, they could consistently apply that by using that kind of shared library. Well, that works well when we only have kind of one programming language or one application, but what if we start to end up with different teams using different programming languages? Well, now I have 3, 4 versions of that shared library. Hopefully we're implementing it consistently and keeping it up to date. And of course, anytime we make a change to that kind of shared library sort of solution, we have to redeploy the application. instead of maybe just updating that sort of layer. So again, lots of ways to solve this. The way that I would argue that it certainly could be helpful for you is a service mesh solution. And so William Morgan from Buoyant, they're the company that kind of brought us linkerd, and one of the early sort of I guess inventors of the service mesh concept, defines a service mesh as a dedicated infrastructure layer for making service-to-service communication safe, fast, and reliable. And I would certainly, the safe, fast, and reliable part, I think we've been wanting that ever since we started building applications. To me, the interesting part here is that dedicated infrastructure that's focused on service-to-service communication. You have some component that's running inside of your environment that allows you to manage and control all of that communication between the services. And typically this is done with two components. There's a data layer that's actually running alongside all of the services, and I'll show you in an architecture picture here next. That's usually done in a sidecar model, where along with every one of your microservices, you have this data plane running beside it and actually controlling that communication, really a distributed proxy. Then you also have the control plane, which is the management components, where you configure, where you read from the service mesh about metrics and so forth. Effectively looks like this. This is the linkerd architecture, but you could think of it as pretty similar to the typical kind of architecture for a service mesh. You can see up top, this is the control plane components. Different service meshes might have different components here. This is my API layer. As an administrator, I can talk to the service mesh and configure how I want it to function and work. This is where metrics are collected. Maybe they're collected in other open source tools like a Prometheus and Grafana that gets bolted on here to allow us to actually view and collect streaming metrics about what's happening in the application. Down in the data plane layer at the bottom is that's where your actual application sits, and this proxy is running alongside it. And in the Kubernetes world, that blue box at the bottom is called a pod. And a pod is one or more containers that run together in something like a Kubernetes cluster. And that sidecar model allows us to make sure that these things are always running together, and then any traffic in and out of my application will actually go through that proxy, and any of the rules that we applied in the control plane above will actually take effect. And a lot of times whenever I share this, the most common question that I get is, well, won't that just slow down my application? Isn't there overhead to that proxy? And absolutely, there's definitely overhead. And generally the goal of these applications is for that overhead to be almost negligible, to be sub millisecond response and so forth. But it's something you have to validate and ensure that the companies building these solutions really provide that. And generally, the more that you layer into that service mesh, the slower it will probably be. Things like TLS encryption are going to add overhead beyond just collecting data and routing and so forth. So what does the service mesh offer besides some of the things that we're talking about? I mentioned observability. I get these kind of interesting dashboards that tell me things around requests per second, latency, size of requests, any kind of failure rates that we may see. And again, I can see this kind of graph on the last 5 minutes, whatever time period I need to look at and kind of do benchmarking and collect information. These tools as well can take the same data and alert me. And so I could even get alerts to find out if response time is sort of consistently above whatever kind of thresholds that I've set. So certainly observability is something that we get out of a service mesh solution. You're typically going to see something like a Grafana or some sort of dashboard that gives you this kind of viewpoint of what's happening with your application. I mentioned the intelligent load balancing. In this case, I have service A talking to service B. It's going to go through my service mesh and potentially stack rank all the replicas for service B and make sure that I'm routed traffic to the ones that are responding the quickest. If one of them is slow or perhaps not responding, it's going to be taken out of that from a load balancing standpoint. And so that makes sure that I'm not just load balancing across this sort of randomly. I'm actually doing it in an intelligent way. And I can do other things with routing and traffic shaping. I could do things like up top here, instead of just routing traffic from service A to service B, I may have a canary version of service B that I want to test out. And so I've already done all my testing in my QA labs and my dev environment. I bring this to production. I'm still going to do a test in production. And that's often done with a canary deployment, where I bring a replica or two of the new version and I route a little bit of traffic over to it. And I can do that on a percentage basis. Maybe 5% of the traffic will go over there. And I can, again, do observations and find out how that canary test is working. The service mesh also might let me do that based off of something in the header. So maybe a particular browser or mobile device will see the new version of the service, and I can test things out in that fashion. And so any kind of routing that you'd want to control based on just labels that identify the different components in your application, you should be able to route the traffic to accomplish what you need. I mentioned encryption. Certainly, this is the kind of thing where if you're working in a kind of a regulated industry or maybe a multi-tenant environment where traffic needs to be encrypted between these services, this is kind of a pain. It's amazingly simple to turn on encryption with these kinds of solutions. All you really do is say, I want to use encryption. And the traffic will automatically be encrypted. It takes care of gathering the certificates from a CA and doing the encryption. You don't even really have to do anything about it. In fact, I was going to do a little bit of a demo of this at some point, but it's hard to tell that it's actually working. We'd have to get a little sniffer going and then look at the data and try to see that it was actually encrypted. But it's a little bit too easy. You probably heard of a circuit breaker pattern. Certainly, this concept, I think, was popularized by Martin Fowler. The idea that, hey, if I'm communicating with a service and it's overloaded, let's not send more traffic to it. Just like a circuit breaker we have in our home for our electricity, we don't want to overload a circuit if it's actually failing. We do the same thing with our services. Services are not only identified as broken and then they're taken out of the mix. When they come back online, it actually is smart enough not to funnel a whole bunch more traffic at it and kind of slowly trickle traffic back to the newly brought online replica. Something like this is again, something you can implement on your own in your own application. And many companies have been doing this for quite some time. This is the kind of thing in a service mesh, I just configure my circuit breaker policy, how I want this to act, and say, these services should use a service breaker, and things like retry commands and all of that happens outside of your code. Your code doesn't even have to understand that the circuit breaker pattern's in place. And so again, super powerful having that without having to write a bunch of extra code. Other benefits, lots of other things that are often offered in these platforms. Things like traffic mirroring. Maybe I want to bring up a new version of my database and route a copy of every transaction over to that database to do some testing. Maybe I want to do things like distributed tracing, where I have all those different microservices. When a user clicks something in the browser, I need to actually trace that particular transaction all through the mesh of services that make up my application. And so we can tag these transactions and trace and figure out what's actually happening on a per transaction basis. We could do things like chaos testing with our service mesh, injecting faults and causing problems and making sure our application actually responds well to that kind of thing. I mentioned circuit breaking. Maybe we could use the service mesh to validate that that's actually working correctly. So lots of other kind of benefits and things that are offered. Again, make sure that you actually need these things. I put this slide in here because I'm out here talking about service mesh. I don't want to imply that you should drop everything and throw a service mesh at everything you're doing. Do you need a service mesh? I think that you should be asking yourself that question. Am I running into these kinds of problems that he's up here talking about? These things add overhead and complication to the environment. The service mesh itself could break. And then your application that was maybe had a few issues now actually has bigger issues attached to it. So you'd really want to make sure that you understand where, am I getting the benefit to the trade-offs that I have here? You can also start small. It's not the kind of thing where you need to bring in a service mesh and layer it through all of the services in every component of your application. You should be able to take that service mesh and maybe plug it into a particular component. Let's use it on this particular service that we have the most trouble with, and maybe not use it everywhere until we fully understand it. And that's a piece of advice I would offer, because I've seen this stuff go really well, and I've also seen it go somewhat poorly. So, what service mesh should you use? I'm not going to tell you actually which one you should use. I do think it's funny, a lot of these terms, when they become popular, like something like containers or service mesh, then all of a sudden everyone has a service mesh. Technologies that aren't a service mesh just start saying that they are. So in my opinion, these solutions are actual service mesh, meaning they have that control plane, they have that distributed proxy, and some of the kind of feature support that I'm describing. The two most popular ones that I'll show here in demos and so forth are linkerd that I showed you a moment ago, and istio, which you probably hear even more about istio, though it's a bit newer on the market than linkerd. And Cilium actually ends up sort of working together with things like istio, but I really view that as something that has that kind of functionality, that has all those components that make up what I define as a service mesh. Now, there are also solutions out there that I would call a service proxy. So Envoy is actually a proxy that actually, in the case of Istio, is the proxy that makes up Istio. We have companies that use Envoy as their service mesh, but they had to write their own control plane. And so I would say this is not a service mesh alone. You need to have those different components for managing it. We do have companies that are actually doing that on their own. They want to customize how Envoy works, and so they effectively built their own service mesh. And you could say the same thing about Nginx, HA proxy. Again, you'll find marketing materials that would say those are service mesh, but I don't believe they are. Also, API gateways. These are great solutions, Kong, Traffic, Tyke. They're exactly just as they're described, API gateways. And in some ways, that does look quite similar. I have all these APIs. I'm providing sort of proxies into them. Is the API gateway the same way? Well, I don't think so. I wouldn't say that it is. But I wouldn't be surprised if these solutions eventually start to kind of morph into a similar concept. And so I think in the long run, this could certainly change. But out of the gate, I don't think an API gateway is also a service mesh. Now, there are other things out there as well. You've probably heard of Console. It's a service discovery solution that's often been used in these kind of distributed systems. They added this feature called Connect, which starts to look and feel a lot like what a service mesh would be. I haven't used Console Connect or Nelson myself, so I'm not really quite ready to move that up into that category of service mesh. But again, I think it's probably headed in that direction. All right. So I've got more demos to do. I don't have a ton of time, but the demos are actually pretty quick. So we only have about 10 minutes left. I want to make sure that you kind of see these. So again, a little bit hard to see in the text here, but we're basically have that layer of APIs that return the data about these services. We're calling into a data layer that actually pulls data out of a cloud database, Cosmos DB. We're going to do a couple different demos. We've got load tests running against them so that we can actually see some data in traffic. So I've actually got some load generators pushing traffic to this environment. And then we'll actually see kind of what's going on. So I've got another cluster with a slightly different issue than what we had before. So again, I have this context switcher with Kubernetes, so I can switch to all of my different clusters that I have running. Now, if you aren't familiar with Kubernetes, you'll see I can take a look at pods and applications that are running in different namespaces. Just so you see from a standpoint of linkerd, this is the linkerd control plane. So these are the components that I actually manage and control my linkerd environment. I have Prometheus and Grafana that do that kind of metrics. The controller is actually the intelligent component of this that's actually doing the work. And then I have a CA that's actually handling any of that TLS work for me, as well as a web dashboard. All right. Same with in this example, I have a series of my own pods and services that make up my application. And so we're going to go out and take a look again at this same front end. Now, in this case, we fixed the weather problem, so weather shouldn't be getting that 404 anymore, but we actually will see some strange results here. And sometimes in these Wi-Fis and in these things, I'll get even worse kind of problems than before. Looks like weather actually is having a problem on this deployment as well. Let me make sure I switched. I did. You can see, if I refresh this again, flights and weather actually come back pretty quick, but Quakes is actually going pretty slow. We could probably count it off here. It could be anywhere from 5 to 10 seconds for it to come back. It does seem as if the Quakes component of this application is having a problem. Our users are calling in, telling us that's the case. How do we figure out what's going on? And just like before, we have linkerd in place here, so we can actually jump over and take a look at the dashboard. One other thing I want to describe to you here, we said that we were having trouble with Quakes. Here's my set of 3 replicas of Quakes API. Notice, by the way, again, if you're not deeply familiar with Kubernetes, this 2 out of 2 is really important. My Quakes pod has 2 out of 2 containers running. So if we go in and look at the definition in here, we would see my API as one of the containers, and you'd see the linkerd proxy as the other. And so this is this sidecar model that's actually really doing a lot of the work for me around my application. And if I go to the linkerd dashboard, it's going to proxy me in to that environment and bring up the dashboard here. And so it actually shows me some statistics. Let's see if I can make this a little bit bigger. Shows me some statistics about my application. And some of the numbers are a little bit hard to see, but generally we see requests per second. We do see some general whether or not we're being successful with our calls. And then we see these different response times based on what percentile they're in. So the P50 response time is our average response time, and then the P99 is kind of worst case. And for the most part, they're all actually measured in milliseconds in the average response time. But as we see here, the Quakes is actually 5 seconds average, which is terrible, and certainly, again, something that I've planted into my code to actually show an issue or a problem. The one thing we could actually do is we could click on this and take a look at these different replicas. So perhaps, again, there's a VM in the environment that's actually having a problem that might affect the response time of these. So we can look at the individual instances of this particular application and see, well, it looks like they're all consistently performing the same. Again, it's a little bit blurry to see the numbers, but it's about 5 seconds average on all of them. So it's no particular instance. It must be something in the code. And we can actually dig into it a little bit further with a Grafana dashboard that they provide in linkerd. And so I can actually click on this Grafana environment, and it should bring up the Grafana dashboard. And so you can see we get a bit more data about this particular API. You can see those response time numbers, not only see the sort of average that we saw in the last dashboard, but maybe I want to see it, okay, what has it been for the last 3 hours? You can see it's not like a new problem. It seems to be consistently wrong. I could actually look and maybe tie this to when we deployed a new version and so forth and sort of dig into the problem. Also down at the bottom here, I can actually, I can look at an outbound deployments, and I can actually see response time of all the calls that it's making out. And I can actually see that if we look at the response time for this call into this environment, the data API is responding quickly. And so we know that the problem is in the code in this particular case. So that's the idea from kind of using these observations in this panel, in this environment. Also, just note here as well, I'm not using TLS for this particular one. It's 0% here. But again, that's a flag I can turn on, and I could actually implement that live in this particular application, and Kubernetes would do a rolling upgrade and actually turn on encryption without actually me having to go in and kind of affect anything in my code. All right. So I'm going to jump out of that cluster and go to the last one and just let you look real quick at istio. Just enough time. So the first thing I want to point out is look at the control plane for istio. We saw a pretty thin set of resources in linkerd. Istio does a lot more. Istio is a bit more of a monster to manage. There's a lot going on in istio. I don't have to turn on all of this stuff. I happen to have it all on for demo purposes. You can control which different sort of knobs and things you want to turn on here. But certainly a lot more complicated and a lot more things that you might need to manage. The thing that I've done with istio here is we'll take a look at the pods that I have running. This is where I want to show you that kind of canary deployment. And you can see from my data API layer, I have 2 versions of data API. I have the regular data API, and I have the data API canary. If I had a bunch of different replicas of this, I only have one of each. I could actually just deploy the right number and kind of get that sort of 80-20 percentage or 95% going to the main deployment. But with istio, I can actually control that with a route rule, or a virtual service, as they call it. And so in this example, I don't know if you can really see that, but basically I've said 85% of the traffic will go to the subset called prod, and the other 15% of the traffic will go to the one that's labeled canary. And by implementing that, istio manages those proxies and actually labels it that way. And if we go over and take a look, istio actually gives you this cool console, and this is kind of the fun, fancy demo part here. But you can actually see I'm pushing traffic into that Quakes API, and you can see it's about 15 going prod and canary. And actually we see that this data API, if I click on this, it shows me that there's these 2 different labeled instances of it. There's a virtual service in place. I could click on a particular one and kind of get detail about that virtual service, destination rules. So this is everything that's going on inside of istio in a clean dashboard so that I can actually manage and understand what's going on. So again, lots of different observations and ability to understand the environment. In this case, I used istio to kind of do that canary deploy. Again, you can use these things to do lots of other sort of things that I described. So with just a minute left, I'll wrap up and kind of summarize for you real quick. I think in general, this is often the problem that we're trying to avoid. This tweet was pretty funny. I give these guys credit. I think the point is we don't want to have this kind of difficult to manage environment. The goal, again, is this dedicated infrastructure layer to help us with service-to-service communication, hopefully to avoid this kind of problem. I also mentioned stand on the shoulders of giants because there's a lot of companies that have already been doing this stuff for quite some time. Companies like Lyft and Twitter and Netflix have built microservices applications at a grand scale. And so a lot of these tools came as open source projects out of those companies. Maybe be some of the folks that are here in the room today. And so it's a great opportunity if we're coming in new to this to take advantage of what they've learned and use those tools so that we don't have to kind of build things from scratch. I would also say it's still an emerging space. And so we're going to see a lot of change. Some of these things are recently become 1.0 projects. And so I imagine there'll be a lot of growth and change, and things will either become easier or evolve quite a bit from here. So that's all I had. I certainly have a minute or two to take a few questions, but I appreciate you guys coming and listening. Hopefully you got something out of it to learn about service mesh. So thanks a lot.